All right, and finally, in example number 3, this is, when we read this, we're going to find we have a rate, we have a time, and then we have a certain amount of people, okay, working on this project to accomplish something. So this is like the old problems, except we're using just, it's all abstract, it's all variables instead of numbers, but rate times workers times times equals accomplished. Okay, and like we did before, we're going to figure out our rate first, and then we're going to put everything in to solve. Okay, it says on an assembly line, M workers worked H hours to produce C articles. If D workers quit, how many hours would the remaining workers have to work to produce the same number of articles? Okay, alright, well with this one, what we're going to do is we're going to, it says how many hours would remain, so we want to solve for time. Alright, in the problem we're going to solve for time. So we could, at the very beginning, we could just get time by itself. So time, we would just need to divide by RW, the rate times the workers. So to get time, we're going to put what we're accomplishing all over my rate times my workers. Alright, and then if every unit cancels out and I have the unit left for days, then I've got it set up right. Alright, well let's start filling in here. First of all, what we accomplished. What are we trying to accomplish? It says if D worked, how many hours would the remaining workers to produce the same number of articles? Now they said that they're accomplishing C articles, so that's what they're going to accomplish. So we'll put C into the ACC for the accomplished there. Alright, now, the workers, let me put C articles, because we want to make sure everything cancels out. The workers, it says that D workers quit. So I started with M workers, and if D workers quit, I now would have M minus the D. Okay? If I had 7 workers and 2 quit, I would subtract to get how many workers I have now. Okay? Alright, now the only thing that we have left is to fill in the rate. Alright, now in order to do that, what we have here is, since we have workers in the denominator, okay, we want workers to cancel out, so for my rate, I'm going to need workers to be in the denominator, okay, under with my rate, and so it's just replacing the weight. I'm going to need the articles up here so that these articles would then cancel out there. Alright, so now we just need to figure out and fill out what goes in those. First of all, for the articles don't change. Okay, we still have C articles. Okay. Now the rate, a little bit different with the rate. Okay, the rate is going to be the articles per worker hour. Okay, since we have more than one variable, so we have per worker hour. Okay, we have how many workers working. We have M workers working for H hours. Okay, so that would be my new rate there. Okay. Alright, so now what we need to do is just solve this, simplify this fraction. We see that my articles cancel out here, my workers cancel out there. Alright, do some more canceling, as much canceling as we can. We see the C's, okay, would cancel out there. So now I would have left over 1 over, I should have workers per hour, put that there. Okay, so hours is all I have left. So I'd have 1 now over M minus D over MH. We want to get rid of that MH. Of course, this is hours. So remember, this is all in the numerator, this is all in the denominator. So if I multiply by MH, that would cancel out. Have to do that to the denominator. So for the time, I would get mh over m minus d hours. Okay, making sure we have enough time. One thing that I think probably would get confusing is the rate. We set it up a little bit differently. So let me go back and show you. I just said that rate would be the articles per worker hours. Let me go into more detail of how I determined that. If you went back from our original equation, if you got R by itself, you would see that rate is equal to accomplished over workers times time. Okay? And that's where I should have explained that first, but that accomplished times workers times time, that's where that rate is going to go. Right there, okay? And you may wonder, well, why is this m minus d? Well, this is m minus d. We subtract the workers, but the rate wouldn't change. Okay, a worker, if you average the rate wouldn't change. It's just the number of workers would have changed to get this. All right, so final answer is t equals mh over m minus d.